Hello and welcome to the HashiCorp Digital 2020 and the session Terraform in Regulated Financial Services. My name is Aymon Delbridge. I'm the head of Cloud Platform Engineering at the Deutsche Börse Group, also known as the German Stock Exchange, and my team is responsible for planning, building, securing and operating the foundational public cloud infrastructure for the group on AWS, Azure and Google Cloud Platform. So we do this in a regulatory compliant way with an extremely small engineering team, currently 8 people, relying heavily on infrastructure as code and automation. And so across the 3 clouds, my team is managing a bit more than 40,000 foundational infrastructure resources. Our product groups then deploy and operate their applications, services and workloads on top of this foundational infrastructure. So during this session, I'm extremely happy to share with you some details about how we're using Terraform and Packer in regulated financial services. But first, I would like to give you a short overview of the Deutsche Boerse Group, an introduction to the regulatory landscape, and a bit about how we define controls to meet ISO standards. And we'll also take a look at the high-level architecture of our 3 CSPs, how we structure our Terraform code base, how we're using Packer, and finally where we're going in the near future. So we're a so-called market infrastructure provider, and as such technology really is in our DNA. Our first fully automated trading system was launched in the 1990s. We're operating extremely low latency networks and the latest technology for high-speed trading. And together with our co-location partners, we're operating one of the largest European financial data centers. All of our core business applications are self-developed and self-maintained, and we accomplish this with about 2,000 people in our IT to provide services across the entire trading value chain. And our core is really trading and clearing applications. And so we use them not only for securities trading, but for derivatives, for currency and commodities like energy. And the Deutsche Börse Group is also offering pre-trade and market intelligence services. So we calculate real-time indexes, for example, DAX and stocks, and operate ultra-low latency data feeds for our customers. Our post-trading area is settlement and custody. And then we have value-add services like investment fund services and collateral management. And so, as the German Stock Exchange, we're really a core element of the European and global capital markets, and as such, we're under scrutiny by the highest regulatory supervision. So not only by the German regulator, but also regulators in Luxembourg, Switzerland, and the UK. And so why this is important to know is that our IT is a product-based organization that aligns with this trading value chain. And this organizational structure is what drives many of our decisions when architecting our foundational cloud infrastructure. So Terraform and Packer are really key components that help us to standardize this foundational infrastructure, and additionally, many of the applications and services that are running on top. So we're using Terraform, Packer, and Console, mostly with public cloud, and like many financial services institutions, the Deutsche Börse Group is using public cloud as one of the main technologies to fuel the foundations for other technologies. For example, blockchain-based services, of course, cognitive technologies, and further big data, automation, and collaboration services. So the shared security model is very important to us. This well-known model divides security responsibilities into security of the cloud, taken care of by the cloud service provider, and security in the cloud, taken care of by the customer. So of course, the certifications, badges, reports that the CSPs can show indicating their compliance with global standards are important. And it's really the starting point of the conversations that we have with the regulators like Germany's BaFin or Luxembourg's CSSF. And since cloud is a form of outsourcing, many of these controls are non-technical. So regulators want to know about the contractual conditions, especially in relation to material workloads, risk management, how we implement controls, what are the processes surrounding controls, and how we can demonstrate that the controls are implemented. And so a supervised company should develop and document a process covering all steps of relevance for outsourcing to the cloud service provider, from the strategy, migration to the cloud, right through to the exit strategy. And so there are several processes, both technical and non-technical, like audit reports, risk assessments, that we can go through to ensure security of the cloud. And for security in the cloud, we can start building in the technical controls for networks, server-specific controls, and the cross-service controls. So where Terraform and Packer really help us is for security in the cloud. This is the ability to provide consistent, repeatable, idempotent, and an auditable way to meet the controls required for security in the cloud. For example, being able to create modules that enable secure access, define role definitions and the user role assignments, ensuring data protection with encryption services, enabling logging and monitoring services by default, and maintaining and applying security policy. And so Terraform is helping us model and modularize these technical controls, and Packer is then helping us with generating and publishing secure and compliant operating system images, which give our developers a head start in their efforts. And so what are the controls? And so we're an enterprise. We have significant on-premise footprint. And as we're planning for our secure cloud landing zones, we've also been considering the infrastructure services, the processes, and controls that we already have in place. And so if we look a bit more into our specific requirements, and we could look at standards like ITIL, SOGP, COBIT, but today we'll take a high-level look at the ISO 27001 controls. And so we've put really some time and effort into identifying here the ones that are most relevant for cloud workloads. And so we can start performing a mapping of the required ISO controls, aligning existing on-premise services and new cloud-native services, which may give us a productivity, cost, or usability improvement. And so with asset management, we can ensure that assets are correctly identified, tagged, and classified. Access control ensures that we maintain centralized control over authentication and authorization in the cloud environments, and that secrets are properly managed. Cryptography, so that we can solve the questions like, how do we remove any possibility that there may be access to data by other jurisdictions, and how do we ensure that the security of the data and systems is also ensured within the entire outsourcing chain. Of course, we need to ensure the integrity of our running virtual machine and container workloads, and we need to ensure that we have the correct controls in place for operation security. And so do we have the alerting, the monitoring, scanning, and detection in place, and how do we help the IT product groups meet these controls? We also need to ensure that we have segregation in our networks, and we can by default provide platform integration with our security incident and event monitoring services. We can, of course, and we do, use the native cloud security services, but then how can we provide this also in a centralized point with a single pane of glass for our security teams? So if we take our controls, we know our requirements, we have a pretty good understanding of a high-level architecture, and so now we can start planning some of these reusable modules and resources in Terraform. So this is pretty oversimplified, but let's go through it. So we follow a hub-and-spoke architecture for all of the public clouds, which is a best practice in enterprise hybrid setups. And all of our connectivity between our data centers and the clouds uses regional and state redundant lease lines, for example, direct connects, express routes, and interconnects. We have multiple hubs. Typically, these are region and environment based, and hubs typically hold the shared infrastructure for then all of the peered spokes. And so our hub module in Terraform would include consistent, repeatable infrastructure, such as VPN termination, shared security services, central audit or SIEM forwarders, published hardened base images, central firewalls, and so on. And so this core infrastructure will also typically contain policy assignments at a root or organizational level, will then propagate through the peered accounts. Policy exceptions can then be made throughout this stack if required, and a typical example of this might be that for cost reasons, we may restrict VM sizes that the users can deploy, but then for special workloads that require maybe GPU instances, we can then apply these exceptions at a product group so that we can enable our data scientists to do GPU instances for machine learning. So peered to the hubs are the spokes, which in our case are the product landing zones. And this is where the work is done by the product teams to develop, build, and run their applications and services. And so our engineers are able to deploy their virtual machines, databases, messaging services on top of this foundational infrastructure. So of course we want to enable our engineers as much as possible without compromising on security. And so we can give the engineers a bit of freedom because the product modules have several guardrails built in, including those policy assignments for the resource types, VM SKUs, regional enforcements, default scene integration. They also include the role assignments for the landing zones. So everything we do is role-based access control, and this is backed by a centralized Active Directory. And so also in the product modules, the integration services and rules for asset management and mandatory security services are implemented. And then we have additional toggleable services which are also possible. And so now with Terraform supporting conditional modules, our product groups can start picking and choosing some of these optional services that they would like to have deployed that are then maintained and operated by our cloud team. And so these can include things like automated start-stop robotics, transparent proxies for that software that just doesn't support an enterprise proxy, and cross-regional peerings for those products that require geo-redundancy. We have Sandbox modules that deploy specific configurations for internet-facing accounts, and these are really areas for experimentation. They have a reduced security posture, and almost all services are provided by the CSPs are enabled here. These are extremely valuable for trying things out and having an understanding of a service before enabling it in one of the connected spokes. And they're also really important that somebody with an idea can get started right away with very little risk to our on-premise infrastructure. And so creating this modular approach in Terraform to define the hubs, the spokes, and the sandboxes allows us to highly automate the creation of new environments ready for different legal entities, the product groups, and the different application groups, application teams throughout the company. And so what does it actually look like in code? So one of my favorite things about Terraform is that there are really so many ways to structure your approach to the workspaces, states, modules, and code. And so from a simple VM with the necessary surrounding services or entire stacks with the interdependencies, we've chosen a structure that works well for us. And it gives us the ability to provide this cookie-cut approach to the product landing zones, with then the additional flexibility for making customizations that are then consistent across the stages from development to production. And what this ensures is that the developers are able to work in environments that look and behave very similar to production. So it's also a structure that has worked for us across our collection of CSPs. And so in each cloud repository, we have an administration folder, which is typically for the helper scripts, the code snippets, and other individual data processing scripts. We have community for the contributions from the internal colleagues. It includes code samples and loading modules. We have Terraform, which is then also the main code base. And so, of course, we have documentation, which is then helping the developers get started in this repository. So let's dive a little bit deeper into the Terraform folder. And so here we can see our Terraform foundational code base. We can see the main modules for core infrastructure, the environmental infrastructure, which is expanded here, and then the sandboxes. And so if we jump into the environment configuration, in this case development, we can see here we have in our top level main.tf a definition of a new product called product1.dev. The product module source you can see here, I will come back to this in a minute, but this is really a wrapper around what we're deploying for each product. We give the aliased provider configuration, and what here is important is that in this case we have an Azure service principal, which is the API client, has permissions only on the product environment that it is managing, and additionally access to the shared hub services, so that we can perform some network peering and role assignments for the central services. And finally, we pass in the product configuration, which is a map object that may contain details like the default values for mandatory tags, service or network configurations, and the custom services that should be enabled. And so if we want to add a new product, it's really just a duplication of what you see here, with a reference to the core product module, with the new provider connections, and a product configuration. And so our product core module references the common DBG product module. This DBG product module is what provides then the landing zones for all of the connected products. And so we need to explicitly provide the alias provider configuration for the hub, and we pass this then on to the product configuration. And that's it. That's how we add, with just a few lines of code, a new product stack in development environment. Of course, the complexity is underneath, but we can then scale this out very, very quickly. And so remember, we have quite strict segregation of duties requirements, and we typically don't give developers the ability to independently create their own networks or expose services externally in the connected product accounts. And so, what happens if a product needs some additional centrally managed infrastructure that should be common across all stages, like new subnets, web application firewalls, or technical accounts? And so this is where our customization comes in. So each product may have unique requirements that are represented here in a customization.tf file. This contains a reference to the module that in this example would create the custom networking infrastructure specific for one service or one application, which then must be common to the product across all stages up to production. And so that means that in production environment, the only difference in the configuration should be the provider credentials and the IP addresses. And so here again, we provide the alias provider, reference to the module source, and some input variables to be used. We can see here as well the two virtual networks that should be peered to the hub. And in Azure terminology, we're providing the IDs of two virtual networks in West Europe and North Europe. And so in this case, we're deploying also some underlying transparent proxy infrastructure, typically required for that software that just doesn't support enterprise proxy, and then merging some additional tags, which gives us the reference back to that centralized asset management service that then associates the application and the infrastructure. And so if we dive again deeper into the modules, we can see a standard module for the hub, for the product, for the sandboxes, for the services, and then the repeatable customization modules for the product groups. And so what we've tried to do is generally provide these modules around a specific function. For example, providing a monitoring module, which may be made up of a collection of different types of resources, or a policy module, which then lets us configure policies that may or may not be deployed to the product. But we know that the monitoring or the network modules deploys a series of services, components, and policy that will then make a consistent and compliant product landing zone. And so now that we've gone through the stack with hubs and product cores and customizations, so in the end, this is a high-level overview of what we've just accomplished. So we have here two hubs for productive and non-productive workloads in two different regions, then peered these to the spokes corresponding to the regions with the network module. We've also deployed role-based access control, customizations, and monitoring. And so now if we needed to scale this for 20, 50, 100 product or application teams, it's just a matter of replicating that core module, and we have a fully connected, secure, compliant product landing zone. And so now that the product groups are able to consume their landing zones and start deploying their application services on top, and so then how are we rolling this out and then maintaining these environments? So we're of course an engineering team, and we need to implement the essentials of secure software development. And so that means ensuring that we have a defined process, that security checks are integrated, and really that we have a life cycle for our software. Of course, an enterprise source code repository fits perfectly this purpose. We also need to have documentation for all of the code changes with a link to a ticket in some kind of backlog. And making fully automated software updates are pretty difficult for foundational infrastructure. And so as a regulated entity with segregation of duties requirements, we need to have an approval process before rolling out anything to production. So we must have code reviews and ensure code quality. And so that as part of our pull requests, we have integrated several actions that do Terraform validate, format, and documentation generation. And then for each PR, after these actions are successful, we'll then alert the configured code owners. The output of a Terraform plan is also posted to the PR, and then the colleagues within the team are then able to approve these code changes. So approved pull requests are then applied to a test environment where some automated tests are run for the connectivity and service onboarding. And if successful, a canary is then rolled out into simulation and the production environments. And so if the canary is good, then the rest of the rollout proceeds, and a release notification is then sent to the cloud community on some of our internal communications tools. And then for Packer, we have similar requirements. Our operating systems baselines are defined by our internal group security, and then we develop against this baseline, following, of course, again, our secure software development processes. We then have several build triggers, either on a weekly schedule, on a new merge to the main branch, or manual. And these are really useful in case of a new CVE or a new kernel patch. And so we also try to keep each cloud independent from one another. And so we use the cloud native CI tooling for controlling the build process. And so on AWS, it's Code Pipeline, Azure DevOps, and GCP Cloud Build. All of our code is stored on GitHub, and all releases are then from the main branch. Packer controls the image creation, so it creates the virtual machine, it calls the provisioner, and then controls the publishing of the image. Ansible then configures the machine, so we have roles and tasks that align to each deliverable from those baseline definitions. We can then generate a compliance score for the image using Rapid7 and InspecIO, and these are performing checks against our internal baselines and also the CIS benchmarks. And so if these meet a certain threshold, then the image is published to a cloud provider. So on AWS, it's the marketplace. On GCP, we have a dedicated project. In Azure, we have the shared image gallery. And of course, these build notifications are then again sent to our internal communications tools. These base images are then used by the product groups as the foundations for their products and services. And so the code is open. We have several contributors from different teams around the internal organization, which is really a great example of internal developer collaboration. And so, what's next for us? We'd really like to implement an on-demand project factory. We're already seeing improvements in our delivery speed in those teams that are using Terraform and Packer. And so we're really looking as well to expand the usage even further, to further accelerate our developers, testers, and infrastructure experts. And we're also starting the onboarding of Terraform Enterprise. And so this will fill for us some of the gaps around single sign-on and role-based access control for the deployments. It will improve control and auditability of the deployment cycle. It'll broaden, I think, infrastructure as code adoption outside the cloud team and provide an approved, compliant resource modules in the private module repository, and then also enables us to do pre-deployment policy checks. And so thank you very much. I want to thank you for your attention and letting me show you how we're using Terraform and Packer in regulated financial services. And so if you have any questions or if you think that we can do things a little bit better, please don't hesitate to reach out.